All right, gang, Math 5130. Starting into two-way ANOVA, lesson 5 will include two-way ANOVA and a brief intro to non-parametric statistics. Two-way ANOVA will be by far the most challenging thing that we do in this lesson, so let's get to it. Two-way ANOVA is a situation where we have a quantitative dependent variable and we want to examine the difference over two independent variables. So we have independent variable 1 with 2 or more levels, let's just say, gender. And we have independent variable number 2 with 2 or more levels, let's just say hospital facility, ABC, whatever it may be. So we have two ANOVAs in one technique, if you will. We call it two-way ANOVA instead of a one-way ANOVA because we have two independent variables. So the criteria for running a two-way ANOVA is we have a dependent quantitative variable and we have two categorical variables, not a categorical variable with two levels, but two categorical variables that we want to examine the mean differences across. So this leads us into something called an interaction. And there's an interaction between two factors if the factors change for different categories of the other factor. So let's just bounce this off an example. Let's say that we're analyzing our quantitative variable, our dependent variable as a score on a final exam. You may think of an undergraduate calculus class or whatever you may want to think about. We have two instructors, instructor A and instructor B, clearly categorical. And we have course delivery, online, face-to-face, or hybrid is our second independent variable, clearly categorical. So we would have what's set up for a two-way ANOVA, again, quantitative dependent variable, and two categorical variables. So our interaction would focus on these mean cells. Instructor A for the online delivery, instructor A for the hybrid delivery, and instructor A for the face-to-face. We would also focus on instructor B for online, instructor B for face-to-face, and instructor B for hybrid. I think this makes sense when you see how each mean would be calculated and tabulated and presented. So let's say for instructor A, instructor B, we're not just interested in the difference in the performance in instructor A or instructor B's classes, and we're not just interested in the difference in online face-to-face versus hybrid, but we're wondering how students in instructor A's class does for each of the online deliveries as we do with instructor B. So for instructor A, let's say the online average was 72, instructor B 76, and so on and so forth. So the interaction effect examines these cell differences. Now it looks like to me, this is just hypothetical data, but it looks like to me because this cell count right here, this 88 seems a lot higher when I just give the eyeball test than the other 5 cells. So it looks like to me we would probably have an interaction effect that was significant. But again, you learn how to use R and/or StatCrunch, and you follow your output and make a decision. So the objective, we have sample data categorized into two factors. We call it a row variable and a column variable. And so in this situation, we would test for the interaction effect. That's the primary importance or our focus, I should say, in this test. And then we also test for the main effects across instructor and another main effect across instructional delivery differences. So the steps are we run the two-way ANOVA with the quantitative dependent variable across two categorical independent variables, and we focus on the interaction effect. So if the interaction effect is significant, we pretty much ignore the main effects and focus on the information provided to us in the interaction. If the interaction is not significant, then we delete the interaction, rerun the model with the main effects only, and examine each main effect separately. And I will give examples of this later in this video, as a matter of fact. So assumptions, very similar to what we ran into in one-way ANOVA. We need normality, variation, I should say normality, equal variance. Samples need to be random and randomly assigned, and we have independence. Now, you should probably already know that Shapiro and Levine are going to play a role in this. So we'll ultimately calculate p-values. We'll end up with 3 p-values. One p-value will be for the main effect on factor 1, independent variable 1, the first categorical variable. In the context of the final exam score across instructor and instructional delivery, the null hypothesis for this would be that the mean score is equal across instructor A and instructor B. The alternative hypothesis would be the mean score is not equal, it's different between instructors A and B. The second main effect focuses solely on the instructional delivery. So the mean score is equal across face-to-face, hybrid, and online delivery. And the alternative would be that the mean score is different across at least one pair of instructional delivery method. So the interaction, we'll get a p-value for it as well. So we say there's no interaction between instructor and instructional delivery method. So for instructor A and B, neither one of these instructional delivery methods work a lot better or a lot worse than the others. Of course, the alternative is there is an interaction between instructor and instructional delivery method. Hypothetical example. Let's say Y measures some sort of political interest, and let's say we took this this poll or collected this data in a large city. So we have some political interest. It's quantitative. It ranges from 0 to 100. 0 is absolutely no interest in politics. 100 is just, you just lose your mind over an interest level in politics. X1 is gender, again, categorical, male or female. The next 2 is education level. They have categorized this as no college degree, a college degree, or a graduate degree. Now, what would we do here in this hypothetical example? Well, we're going to have tunnel vision on what is enclosed in the red box. So first of all, I'm going to look at the main effect of gender. I'm going to come over to the p-value. This is an SPSS output. They do something kind of goofy, I think. They call it, instead of a p-value, they call it sig, the significance level at which, well, this is just the p-value. Let's not make it more than it is. So the p-value for gender would be 0.448, so we don't see any difference in political interest, mean political interest across gender. The next thing we would do is we would look at education level. That's another main effect. Well, when I come over to the right, you can see that we have statistical significance at the 0.001 level. So we have statistical significance there. But circling back to what I talked about earlier, when we have the interaction in our model, we have tunnel vision on the interaction. So in this case, the interaction, gender across education level, you can see right here, statistically significant at the 0.01 level. So I would ignore gender, I would ignore education level, and I would dive into the techniques that I'm going to teach you to examine the mean differences across the interaction of gender and education level. So since the interaction is significant, we kind of ignore the 2 main effects and focus on the interaction. So here's the second example. Here the dependent variable is some sort of math score. Again, it has to be quantitative. The independent variable 1 is environment. Independent variable 2 is instruction. Both of those, again, have to be categorical. And then the interaction is environment across instruction. Different statistical software packages do this differently. This actually comes from R, and it uses a colon to display the interaction. Well, I come over here to the main effects. Environment is not significant. Instruction is not significant. And environment over instruction is not significant. So again, the first phase, I have tunnel vision on the interaction. Since it is not statistically significant, I would delete the interaction and I would rerun the model with the main effects only, environment and instruction, and not the interaction. And that's really easy to do. You might look at the code they've run up here. They use this asterisk. You just change it to a plus, and it'll just examine the main effects instead of the interaction. So it's doubtful that either would emerge significant since both of these p-values are high, but that's the process that we would carry out. Now, let's circle back to this instructor and delivery method example that I started out with. So we're looking at exam score, mean exam score over instructor A and B, and delivery method hybrid, online, or face-to-face. What would we do if our main effect for instructor was 0.028? Our main effect for instructional delivery was less significant at the 0.001 level. So the main effect for instructor is significant at the 0.05 level. And then the interaction effect has a p-value of 0.28, clearly greater than 0.05, so it is not statistically significant. Well, since the interaction is not significant, we'll delete it and run the main effects only. So let's say that we do that and the main effect for instructor turns out to be 0.056, not statistically significant at the 0.05 level. The main effect for instructional delivery method is significant at the 0.001 level. Since main effect of instructor is not significant in the updated model, we will ignore it. So we'll focus solely on the instructional delivery method since it's significant. Recall that instructional delivery method had 3 levels, face-to-face, online, and hybrid, so that dives us into a one-way ANOVA, which we studied in lesson 4. Now, just a FYI, if instructor level had been significant, then we'd investigate further with the 2-sample t-test. Since instructor was A and B, 2 levels, a t-test, a 2-sample unpooled t-test would be appropriate. All right, gang, we got a lot of stuff to learn. This is good stuff, right? All right, take care.